All right. So yeah, there are a lot of topics behind neuroimaging, and a long history started since the last century. And I'm not trying to, before breaking the ice, and I want to go ahead, but you need to know that neuroimaging is today, you know, is today the most important topic to discuss regarding neuroscience. There are no needs to surgery again. Craniotomy, lobotomy, and all types of neurosurgeries are today out of date and not too efficient to cure neuropsychiatric diseases, especially, and to cure um, today's neurological diseases. Because if you open an encyclopedia, for instance, like Douglas Gelb or Gale Encyclopedia for Neurological Disorders, one of the most important and well-known encyclopedias regarding the neurological disorders, you will find that there are hundreds and hundreds and hundreds, maybe thousands of neurological disorders. And there are too many of them are related to the personality disorders and related to some behavioral neuroscience based disorders. But in fact, it's not. It is returning to neurobiology again. It's all returned to neurobiology as the core domain of these disorders. And neuroimaging is a thing that we happy to know more about it before it's too late. Why? Because most of the biology themes regarding molecular biology and regarding epigenetics and regarding each theme of biology that serves curing typical diseases will end up with neurotechnology and neuroimaging techniques that not only diagnose and not only help us for guidance of treatment, but can indeed give us treatment methods and actually treat, and cure the diseases in a typical manner. Without further ado, let's go ahead. So as we said earlier, it's about alignment, movement. Okay, it's about enlightenment and movement at the beginning of research into the smallest details of the brain, as I said earlier. And it's also collect all our knowledge of neuroscience.
Sorry to interrupt you, Ashour. Please, Mohammed, can you mute? So please, if you're not speaking, kindly mute your mic so that it does not disrupt the presentation. Ahmed, you can go ahead. Thank you.
Okay. So yes, and the predominant thing regarding neuroimaging is the total understanding of symptomatography that we will discuss later on in this session, which is very important, really, really important for diseases like depression and schizophrenia that till this moment, there are no distinct ways and distinct differentiation ways that we can differentiate between in terms of diagnosis, of course, schizophrenia and depression. And so we led to and we rely mostly on excluding the symptoms, excluding the negative symptoms and the dual symptoms between both diseases. So there are so many gaps in our history of neurobiology that can be served if we really applied neuroimaging techniques in a broad scale. Okay, so let's go ahead. Okay, so it plays a critical role in psychiatry, as I mentioned earlier. Not only in neurobiology, You know, there's hundreds of diseases that are mainly called under one heading, which is personality disorders. And personality disorders can be divided into many typical disorders related to behavioral neuroscience and related to psychiatry and psychology, you know, and we can go far, far away from neurobiology. So in the sessions that are made by those psychiatrists and psychologists who try to implement ways to gather these people who are the patients, I mean, and try to educate them about their personality and educate them about life and educate them about topics, and you know, doing these circles and all that stuff of social savoring, of trying to raise their self-esteem, and all these types of interventions that are today not up to date. We have in our you know, for instance, if you made an estimation or try to get percentages about the people who have personality disorders, not like depression and not like schizophrenia, and you know, not neuropsychiatric diseases, but really behavioral diseases, you will find that after years from them, it will be classified as neurological disorders, just like depression in the first segment decades ago, when it was not considered as. So that and also it returns to the biomarkers in which people can indicate these. You know, epilepsy, for instance, if you know, epilepsy is treated by some types of diets, and you know, like keto diet. And for instance, epilepsy and other similar diseases that have you know, these seizures and cycles and so on. It relies on biomarkers in terms of diagnosis and the performance of the patient from the early beginning of diagnosis until he is being treated in a cycle of treatment. The biomarkers is the thing that we rely on as doctors and as neurologists by as I said, like diets and by some typical implementation, and also by neuroimaging, like for instance, the PET scan that we will discuss later on. The PET scan shows you the biomarkers of the disease and the prognosis and the treatment, and you know, we show you the biological pathway, show you all the metabolism behind the disease. But it's not sufficient, because even the biomarkers are now less accurate, and in the future we rely mostly, of course, you know, on the personalized medicine, as symptoms year after year are being so hard to detect. Diagnosis is being the problem of the disease rather than the treatment in the last few years. And neurotechnology and nanotechnology and nanochemistry using biosensors showed us different types of biomarkers that that no other tools and scanning tools and diagnosis tools and diagnostic tools can see or can detect. So that's another feature that, you know, that concern us about the future without nanoimaging, without neuroimaging techniques. Sorry, without neuroimaging techniques. So and also there's a there's an intertwining between nanotechnology and neurobiology in terms of making a biomarkers that the advanced neuroimaging techniques can actually detect. This can make a multimodal type of accurate detection of disease based on metabolic interactions, which is great. For this reason, as I mentioned, some typical types of imaging are being correlated and are being added together. You can improve some types of imaging techniques and try to mix them or make a new type of imaging, like what happened to MRI, to be the UHF, ultra high field MRI imaging, which is the from a research that I was taking. I'm sorry because this this slides lacks resources. I didn't have the time to put them, but I have already had them, and by the end of the session, I will send it with the resources, of course. But if you look to the history behind this, in this year, in 2024, there was a typical type of MRI version, which is the ultra high field, was introduced in centers and research centers that cure and deal with neuropsychiatric disorders. The UHF MRI imaging offers significant advantages in terms of spatial resolution, something called signal to noise ratio. And it can be also used in clinical relevance and clinical studies that aim to understand more about the complex brain functions. And maybe also this is, it's open up a new topic that we will discuss later in the session, which is understanding the disease and indicating the future in the same time by having a great background about what the neurobiology research, which path that neurobiology research has to go through it. And I will discuss one of the experiments that was done to understand the secret of the brain, which is the prefrontal cortex, the place where most of the complex abstract functions relied on in its ganglia and its interneurons, nuclei, I'm sorry, and interneurons. Okay, so why is so important? Maybe I've answered this question from the beginning of the session till now, mentioning things like treatment, research discovery, and as written here in this, you will see neuroimaging fundamental benefits in terms of treatments and in addition, a scientific exploitation, which is notably detected in the last 2 years. If you've looked to the new diagnostic methods that we will discuss also here in this session for diseases like schizophrenia, for making something like SchizoNet. SchizoNet is a new method of diagnosis that implement all the diagnostic features of the negative symptoms of schizophrenia and try to reflect it on the patient, including all the new symptoms. I try to relate it using data analysis and using neuroimaging techniques like fMRI to try to understand better if this patient has schizophrenia or depression, and so on. Okay, and the insisting need. From the headline, you can see how the future is aiming for in terms of neurobiology and its research development. So neurobiologists, as I said, the experience with schizophrenia and depression, because most of the times, especially now, after the complexity of the symptoms and the new era of diseases that we are facing each day, it is hard to differentiate between both. Most of the people, most of the doctors who have these typical cases, they rely on exclusion. So they exclude the symptoms until they find, and there is a movie, and I'm sorry, I didn't remember the name of the movie, of someone who has depression and schizophrenia at the same time, and he was advised to take, drugs related to schizophrenia mostly. But this is happening in real life, not only in the movie. Okay, so and neuroimaging by its advances can discover this. So what also we need from from neuroimaging is the help to make a symptom-relevant experimental manipulation. And what the sentence actually means is the specificity of symptoms, and in addition to the organism of its interventions, to enhance rapid clinical relevance tools utilization, and try to make the process of diagnosis and treatment known with a guide, total, completed, organized, utilized guide to try to manipulate the steps that may be needed according to the case. So let's say if the case is so new for you as a neurologist, and you applied then the well advanced developed neuroimaging techniques that gives you the symptom relevant experimental manipulations, and you can see by yourself the guide and how to do with this patient. You of course know how to diagnose him. Of course, you know what is the disease that he's carrying, and how to treat him, and how to use your tools. And in addition, if this patient has something that is more new in his case, then you will know how to apply your personalized medicine for him, how to apply, how to manipulate the new steps. Why? Because the guide helped you in the beginning to understand his case, and then it makes it easy for you to continue to go through the process until to be cured in the end. And as I've said first, the relation between nanotechnology and neuroimaging, and how the new biomarkers and new biosensors that are being made by nanotechnology is being detected by the new advanced developed techniques of neuroimaging. Okay. Studies in the past few years aim to make imaging informed decisions at the individual patient level, and especially according to the priorities set by the patients themselves. It was written by from a journal that was released in the past few months regarding applying neuroimaging to neuropsychiatric centers and to rely on it. And it can give you some indices about how more easy is these techniques, and how it can compel all the community to understand his needs for being well treated, for his treatment, and for his health and and his brain health. So it inform you about the decisions that you as a patient and you as a doctor can take, the guide, as I've said earlier, the priorities, and the handbook of the treatment method that is written by this tool. Okay. So the implications, as I said, the patient, the early diagnosis and intervention, point of care monitoring, which is it can give you the map in which this patient will go to specific type of clinical care, specific type of medical care, specific type of personalized medicine. And of course, it can enhance patient with comfort. As I said earlier, it is something about taking your decision about your treatment, how you can choose to be healthy, and I mean how, because you already know through the process and via the techniques that you're using. Through treatment, it can give tips about the targeted therapies and drug development and clinical trials. And here's an application was done about the fluid biomarkers for people who are diagnosed with Parkinson's disease. Recent studies showed that the ultra high, the ultra high field MRI imaging technique, which shows some biomarkers that is related to Parkinson's disease more than the biomarkers that we have already known about the disease, like the loss of the neurons and problem with the neural mitochondria, and of course the secretion of neurotransmitters. It can show you more than about these markers. Why? Because as I said, the accuracy and the efficiency and the efficacy of these tools to try to give you a complete guidance of the case, whether it is Parkinson's disease or it is some other type of Parkinsonism related diseases. Okay, so neuroimaging, well-known methods, of course, we will speak more about both of them, but fMRI and PET and SPECT scan, which are bonded together. We will know more about the functional and the structural neuroimaging, the structural and the functional neuroimaging techniques. Of course, we will see that, on the year of 2006 is the year of the threshold of using predominantly the neuroimaging methods in order to diagnose the cases, in order to give information about the prognosis and the treatments. Okay, so what is the difference between the structural imaging and the functional imaging? For the structural imaging, it focuses on visualizing the anatomy of the brain, more about the morphology, the structure of the brain. It can give you, for instance, for the people who have Alzheimer's disease, if you have seen, there is a video made by Professor Peggy Masson on YouTube. You can check it, where she carried in the University of Chicago, in the lab of neurobiology department. You will see her carrying a brain without a hippocampus, and carrying another brain including hippocampus. You will see the difference between them. One of them is having Alzheimer's disease and the other is not. You will see the big difference between both of them, and how how a disease, a neurological disease, is being detected. Let's say young onset Alzheimer's disease, and the patient, for instance, is having 45 years old, so is still young, comparably young, and he's being, through the computed tomography and through the magnetic resonance imaging, indicated that this person will experience in the future Alzheimer's. Small, very small, frequently small changes in the structure of the hippocampus can show you through the imaging how this patient will experience. Okay. And also the functional imaging that investigates brain function by measuring activity of metabolism, like I've said, the fMRI, for instance. And the thing that is about functional imaging is that it's used to study cognitive processes and diseases like epilepsy, and more about Alzheimer's in the later stages, and can if you are asking the patient who is being under the fMRI, you can ask him for doing some tasks and to respond to some stimuli, and he will do so through while he is applied to fMRI. So let's know about the types of neuroimaging themselves. Let's try to. I know it's some it is a little bit naive to speak about each topic itself and each method and know what does he do and so on. But let's discover them in a broad fiction. The CT scan and MRI, which is bonded together, can detect the fractures, dentures, bleeding with high accuracy. It's a computed tomography that can give you accurate images about not only the brain, can give you about the chest. There's a bleeding also that shows it in an accurate manner. And we have also the fMRI, which is the mapping. It maps the activation of the parts of the brain map while tracing each part. It can help you in understanding the neural correlates of cognition and emotions. It can being applied to tasks while in order to show you in order to reflect directly on the imaging technique. Okay. Okay, you can see here in the fMRI image, you can see here difference in the neocortex, especially for the near the motor cortex, some of the sulci and the prefrontal cortex, and other here, it is very near to the somatosensory cortex. And of course, the EEG imaging. But before the EEG, we have the DTI, which is the diffusion imaging. See, that diffuse the images and can relate fMRI to MRI together. It shows can show you the brain waves of the patient, and the brain waves is a broad topic. It can you can see a video made by Joe, I think Joe Spezia or Spezia, I think. He was talking about the brain waves and how the brain waves can indicate the features of the unknown features of the brain that we until now don't know it. The atomic habit, more about the atomic habit, of course, because we know more about it, but not all of this, not all of the information regarding this topic. The rational thinking and the mathematical thinking and the reasoning, and because we all know the location of them, we don't know the typical location, the typical singulate, the typical nuclei where these features are being decision making and so on, where these features are located inside the brain, inside. And we have lastly the PET scan and EEG imaging. The PET scan is measuring the biochemical and physiological processes in the body, especially the brain. It can reinforce researchers to discover the brain functions. And here's the thing. It can also being used with DTI to see the brain waves. But the PET or the PET scan was used by a scientist years ago. I think 3 years ago, by a neuroscientist called Watanabe. PhD in I think mathematical neuroscience or computational neuroscience. He's working on a project related to computation neuroscience to try to understand all the features of the prefrontal cortex, the secret of the brain, and it's still secret until now, and we don't know all the features of the prefrontal cortex. Okay. And in addition, we have the EEG, which is for localizing the seizure activity. It is used for people who have epilepsy and used for people who have seizures or episodic seizures to monitor their brain status. And it's also used to indicate brain waves in addition. And if you know this concept, you will understand some people who die. You know, it's a story was told by a neurologist who was doing EEG. It's not out of scope, but I will recite it. You know, there's a belief in many religions like Islam, Christianity, and I think Judaism as well, and other religions, that when the person dies, all his memories came, you know, he sees again all his DVR inside his brain is recording and is releasing all the recordings again. So all he see in this moment while he's dying, all the memories of his brain, all the memories and all his history in front of him. And this neurologist who was applying EEG imaging, he assured that you know, he saw in the guide he was given to by his nurses who were helping him with this patient, that at the moment when this patient died, he saw like pulses in all his brain, in all his entire brain, all the neocortexes, all the you know, all the sulci that contains the memories. I know that memories location is something also you know, not very known or not totally understanding by people who are people who are studying neuroscience. But we have an you know, estimation that the memories are being saved inside our neurons, interneurons, and inside our sulci and gyri, these convolutions in our brain. So we saw that all the EEG pulses, he saw pulses in all the patient brain in the moment when he dies. So it was a story to wonder. It also guides treatment decisions. Also, neuroplasticity can be showed by EEG imaging. Neuroplasticity is related to the interactions between the neurons and you know, between the interneurons. It is an interaction between the interneurons, especially. For people who have autism, they are their doctors apply EEG imaging on them to try to see the development of their treatment. it's a crucial for autism, actually. And it's really helps in treatments. Okay, so the history behind the usage. As I've said earlier in this session, lobotomy and craniotomy, we want to avoid them. Why? Because if we open the brain and we try it by all the accuracy that we have to not make any side effects while we are cutting, for instance, the bridge between the hemispheres, the corpus callosum. You know, there might be a lot of side effects, and even if we made all the tests and the experiments and all the, the post surgery tests to the patient, try to fully understand what he has experienced after the surgery, and I try to understand his status and if he's losing any sense or is losing any ability or so on. We will not do so. We will not actually do this in 100% with 100% efficiency. So we try to avoid craniotomy as much as we can, and lobotomy, of course, but craniotomy as well, to any brain surgery, any brain open surgery, in order to avoid these type of cases. And if due to the time of the session, I was to tell you more about examples of the side effects that is disastrous, can cause a lot of consistent disorders. So since the last century until now, we are developing our tools. We are developing our imaging techniques as people of neuroscience. And the last update was, and we will talk about it, was 7 Tesla MRI with 10 microns isotope resolution. It was made to understand the behavior of each neuron functionally inside its cortex. And what is interesting that there is an increase in interest in integrating, as I said, like the UFH. There's another attempt to integrate fMRI and MEG, for instance, that can help widely in making a complement of these imaging techniques to try to have, a result in high precision of indicating neural oscillation. And neural oscillation is something not related to, it is something that is not actually related to neuroplasticity, but neural oscillation is about perception and integration inside the brain in terms of their speed and in terms of their arrangements. But it needs advanced level of data analysis. We will talk more about the future of neuroimaging in the subsequent slides. But in terms of data analysis, we really need data analysis, advanced techniques to try to keep up the developments of these neuroimaging techniques. This multimodal approach can be applied in cognitive neuroscience, by the way. Cognitive neuroscience. And here's the SchizoNet project that emphasized the analysis of the brain networks and by applying the functional neuroimaging, which is functional MRI, to connect it with the brain networks and the reasons of each epileptic episodic seizures of schizophrenia. Try to understand it and try to understand the negative symptoms of schizophrenia as well. So it's a diagnostic tool. It's a diagnostic tool. And you will see if you open the Gale Encyclopedia and saw all the neurological disorders, you will find that a lot of them, especially the neuropsychiatric diseases, most of them rely mainly on it's a complexity rely heavily on its diagnosis, how to diagnose the disease, and then you can how diagnose the patient, and then you can find a treatment. Okay. Here's an example of the 7 Tesla MRI, which is the last update. You will find here how the cell chi, this convolution, you'll find that the convolutions, the cell chi gyri, the convolutions of the brain, how it is very, and by the way, the resolution of this image, especially as I talked from the internet, is not, it's not so high, but the image itself, it shows you a lot. And if you are, if you have experience in this field, you will see how more advanced it is. And you can see here the TTI and the image that is above, how each neuron is actually being shaped, and maybe you can see also if you apply more techniques, you can see the oscillation, the neural oscillation from here. And now, here's the thing that we need all to understand. In the recent studies, and from the beginning of this year, 2024, there are many momentum to apply and depend on, or you could say, compel the neuropsychiatric centers and institutes to rely on neuroimaging techniques, primarily in order to understand the challenges of psychiatric diseases. As I've said, it's a challenge, it's of course why can't we apply neuroimaging always in any neuro-related disease? There's a lot of answers, and the easiest one is related to the costs, of course, the applicability in each country, in each state, and also the will. I think it is related to the will of these centers. And I'm saying 2024, so it is this year, very recent to say that solidifying, applying neuroimaging with clinical relevance for individual psychiatry patients is a must. And instead of using the biomarkers that ultimately fail to replicate the cases, if we are people who don't have capacity to personalize medicine, we should indeed find ways to take it seriously for applying and compelling neuroimaging techniques in these studies. Because relating biomarkers to behavioral aspects of prospective patients who are accused with PTSD, certain stages of autism, traumatic brain injury, TBI, maybe personality disorders. All these diseases are heavily connected with the changes in the brain and changes, especially in the brain abstract functions, which must be taken seriously by applying neuroimaging techniques. In addition, we need to, as I've said, to especially after as I've said, the variety of the techniques and the developments of each one and the versions of each technique, especially fMRI, there must be an effort to standardize imaging protocols and data analysis, and in order to find a resolution or a guidance to avoid I am naming it as the neurological diseases diaspora, where each typical case has a typical disease, needs a typical treatment that leads to a typical cure or a typical development or prognosis. So, we need to make a constructed scientific robust, especially as we have mentioned earlier, the variety of versions of MRI and so on, to ensure reproducibility of findings, and to find it clear to solve this issue. This is our stance. Now, okay, now we are almost about to end the session, but before, I need from you all, this is something to try to not to make the session. I know I don't want to make it so passive, but to be more interactive. So we need to settle down all together all the societal aspects of neurotechniques. What do you think? And what do we think as people of Africa? How can we apply neurotechniques in each neuropsychiatric center, in each neurobiological center, and make it easy to apply it and make it a dominant technique to understand neurological disorders in our content? How do you think? And
So because of time, I don't know if you saw my message. Is it possible to move this question to the end? If this is not the end of the session, because we do need to wrap up by 9:30.
All right.
Is this the end?
Oh yes, this is so. This is almost
Okay.
yes, the end, and we. I hope you. I hope I didn't distract you with the variety of information and because there were a lot of topics that was being opened and didn't end. So I hope you understand something. I hope you got some things to be considered for future references. And thank you.
Thank you. Actually, yes, we did. I think it was quite fascinating to hear you talk about um, the scientists and what they discovered with people and their memories when they're about to die. That was some kind of tricky research, and I was just thinking about how that would have been possible. So yes, it
Yeah.
was just really nice to learn about neuroimaging in that way. So very quickly, we'll just entertain one or two comments and questions um on the topic, and it's because of time. We have members in different time zones, so we have to ensure that we close exactly by 9:30 WAT. So we can just continue that conversation on WhatsApp after this session is done. So please, if you have questions or comments on the presentation, please feel free to just share what you have. I'll just take one or two before we close. Thank you.
Thank you so much. Thank you, guys. If anyone have any question, don't hesitate to ask. If not, we can end the session. Um, I hope Rotha. Okay, I hope Rotha don't kill me while then. Okay. Um, thank you all. Um, um, I will stay in the session until the end. If anyone have any question, uh, please ask and open the you know the mute button and ask me. I will be so happy to answer. Okay. Oh, I have discovered that I'm enrolling in the session by a wrong email. This is not the
Oh,
email,
oh,
email that I have for
oh,
Biospherea.
that's fine.
Okay.
Oh, I was just asking that after this session, would you share your slides on the WhatsApp group? Is it possible that
Yes,
we
I will
can
do so.
have them so that other community members
Yes, I will do so.
too?
Just citing. And,
All right.
yeah. I'm writing my email, my email for also that I have uh, enrolled in the session with the wrong email. So
Oh, oh, okay. Okay.
this is the
Yeah, so please,
okay.
yeah,
Mhm.
thank you. I was actually referring to WhatsApp. Um, I mean, just like sharing your slides on the
Yes, yes,
WhatsApp.
yes, I will do so. I will do so. I
Yes.
will share it on WhatsApp right now.
Yeah. Thank
Okay, thank you.
Yeah,
Uh,
thank you so much. Yeah, so I mean, community members are just saying that it was a very nice presentation. I think some people would probably just go through the slides again, and if they have questions, they would just share. So at this point, I just want to thank everyone for joining this session. This was really good and very detailed, Hamid. Well done. And yes, thank you, one of our youngest members, by the way. Um, so on that note, after you feel the session, I just encourage everyone to have a lovely night. And thank you, everyone, and good night.
thank you all. Thank you, Martin. Thank you, Rod. Thank you all, guys. And yeah, I will end the session right now.
Thank
Okay. Bye. We'll chat on the. If anyone have any other question, you can directly ask me or mention me
you, of
in,
course.
and I will be happy to answer.
Yeah.
Okay.
Thank you.